this problem, we're going to be dealing with complex numbers. So please read the question carefully, and then we'll go about solving the problem. I've written the main points on the top right hand corner of the board so that we can keep an eye on the problem at the same time. So let's start slowly. We're given that z, or some of you may want to call it z equals to cos theta plus I sine theta, and we are told in the problem that theta is between pi over 4 and negative pi over 4. Okay, and we are asked to find z cube using the binomial expansion. So let's start. Z cube will be equals to cos theta plus I sine theta, whole thing raised to the power of 3. So we're going to be using the binomial expansion. So let's start slowly. We will have cos cube theta, first term, plus 3c1 cos squared theta and I sine theta. Next term will be 3c2 cos theta I sine theta squared, and finally we have I sine theta, whole thing to the power of 3. So now let's write it in one line. So I have cos cube theta, that's good. Okay, let's write it down. So I have cos cube theta, my first term. 3c1 is 3, so let's write the I in front. I have I 3 cos squared theta sine theta. Then my next term I have 3c2, 3c2 is 1, and I have I squared here, so I squared we know is negative 1, so I'll have negative 3 cos theta sine squared theta, and then I'll have I cube sine cube theta. So I cube will be equals to I squared times I, which will be minus I. So we have minus I sine cube theta. Okay? Now let's just write it with the real parts and the imaginary parts. Let's collect some terms. So I have got cos cube theta minus 3 cos theta sine squared theta, and I have my plus I 3 cos squared theta sine theta minus sine cube theta, and we're done. Okay, that's good. Then the question goes on to say, use De Moivre's theorem to prove some identities. So let's start with cos theta plus I sine theta using De Moivre's theorem to the power of 3 will be cos 3 theta plus I sine 3 theta. Okay, you need to know that. So what do we see from here? Okay, we can write that cos 3 theta here, okay, we can write it as the real part of cos theta plus I sine theta raised to the power of 3. Okay, as you can see, this is the real part and this is the imaginary part. So cos 3 theta is the real part of this complex expansion. Good. So what's the real part of this? We have that, yeah, from the earlier part. Okay, this is the real part. So we can write cos 3 theta is cos cube theta minus 3 cos theta sine squared theta. Okay, so let's clean this up a little bit. I have cos cube theta minus 3 cos theta What is sine squared theta? 1 minus cos squared theta. So, cleaning up your terms, let me write one more line so that all of us can see it. Minus 3 cos theta plus 3 cos cube theta, and you'll get the identity that you want. This will be 4 cos cube theta minus 3 cos theta. Okay, so that's what you see here. They ask you to show using De Moivre's theorem that cos 3 theta is 4 cos cube theta minus 3 cos theta. Okay, so we are done with that. We will use similar reasoning to deal with sine 3 theta. So I am going to erase this. Okay, I'm going to erase this. So now we will consider the imaginary part of this complex expansion. So sine 3 theta, okay, as you can see from here, this is the imaginary part of this expansion. We can write the imaginary part of cos theta plus I sine theta, whole thing raised to the power of 3, the imaginary part of that. So what is that? We have it here, this part here. So let's write it down. We have 3 cos squared theta sine theta minus sine cube theta. Okay, I'm just copying this down. Now we need to clean this up. Cos squared theta is 1 minus sine squared theta. So let's write it down. 1 minus sine squared theta sine theta minus sine cube theta. So I have 3 sine theta minus 3 sine cube theta. All I'm doing is expanding. Yeah? Okay, to write in the form that we want. So I have 3 sine theta minus 4 sine cube theta, and we are done. So that's what you see given the question. They ask you to show that sine 3 theta equals 3 sine theta minus 4 sine cube theta, and we are done. Okay? Good. So let's move on to the next part. I don't need this, so I will erase this and continue writing here so that you can follow the logic. The next part, they ask you to prove that sine 3 theta minus sine theta over cos 3 theta plus cos theta is tangent theta. So let's look at the identities that we proved earlier. Okay, so let me write sine 3 theta equals 3 sine theta minus 4 sine cube theta. Okay, let's use the identity. Now I want to bring one sine theta to the left, so this becomes sine 3 theta minus sine theta will be equals to 2 sine theta minus 4 sine cube theta. Again, there are 3 sine theta here. I brought one sine theta to the left, so it becomes sine 3 theta minus sine theta. So I'm left with 2 sine theta minus 4 sine cube theta. Good. I have to do something similar to cos 3 theta. Okay, so let's look. Let me write it here, and I can bring that. Let's write it here. Okay, so cos 3 theta will be equals to 4 cos cube theta minus 3 cos theta. We just found that. So what do we do? Let's bring one of these cos theta that you see on the right hand side. Let's bring it to the left. So when you bring one of the cos theta to the left, it becomes cos 3 theta plus cos theta equals 4 cos cube theta minus 2 cos theta. So please be careful about these things. Yeah, we're just trying to play around with the expression so that we can get what we have here in the numerator, sine 3 theta minus sine theta. We have that, and what we have in the denominator, cos 3 theta plus cos theta, which is 4 cos cube theta minus 2 cos theta that we have here. So now we need to take a ratio of those, one divided by the other. So let's write it down here. Okay, so it will be 2 sine theta, watch carefully here, minus 4 sine cube theta, that's the numerator, and we're going to divide it by the denominator, which is 4 cos cube theta minus 2 cos theta. Okay, now that I've written this out, we don't need this. I can erase it. Okay, I can erase it so that we can see the working quite clearly. 2 sine theta minus 4 sine cube theta divided by 4 cos cube theta minus 2 cos theta. So this numerator here, let's take out 2 sin theta. So what do we end up with? We have got 1 minus 2 sin squared theta. Okay? If I take out 2 sin theta here, factorizing, yeah, I'll have 1 minus 2 sin squared theta. And the denominator, I'm going to take out 2 cos theta. So when I take out 2 cos theta, what do I get? I have 2 cos squared theta minus 1. Okay? You can check when you expand the bottom, you'll get 4 cos cube theta minus 2 cos theta. Exactly this. When you expand the top, 2 sin theta minus 4 sin cube theta. So you've done it correctly. So now we can pull this up even further. And we're almost done. What is 1 minus 2 sin squared theta? And what is 2 cos squared theta minus 1? They are both equal to cos 2 theta. Okay? 1 minus 2 sin squared theta and 2 cos squared theta minus 1, they are both equal to cos 2 theta. So we can cancel. This 2 will go and we are left with sin theta over cos theta. What is that? Tangent theta. And we are done. Okay? So we are good up to here. And then we are given sin theta is 1 over 3 in the last part of the problem. We are asked to find the exact value of tangent 3 theta. Okay, so let's start. I don't need all of this, so I can erase it. Okay, so let's look at the trigonometric ratio that they've given us. Okay, sin theta is 1 over 3. So let's use Pythagoras theorem and a right angle triangle. Sin theta is 1 over 3, so I have my opposite and my hypotenuse. So my adjacent will be 9 minus 1 will be the square root of 8. Good. Now, I have my identities here, sin 3 theta and cos 3 theta. So I know that tangent 3 theta, okay, will be sin 3 theta divided by cos 3 theta. Good. So let's borrow the identities from what we just found. So I have 3 sin theta minus 4 sin cube theta. Good. Over 4 cos cube theta minus 3 cos theta. I'm just using these identities. Cos 3 theta is 4 cos cube theta minus 3 cos theta, as you can see here. And sin 3 theta is 3 sin theta minus 4 sin cube theta. We are done. All you need to do is just plug in, yeah? Sorry, I didn't label this theta. I should have done that. Okay, now you have theta, you have all the values that you need. Just be careful with the plugging in. So I have 3, what is sin theta? 1 over 3, that's good. Okay, sin cube theta will be 1 over 3 to the power of 3. Don't forget there's a 4 here. Okay, the whole thing divided by 4 cos cube theta. So cos theta will be square root 8 over 3. So let me write it in. Minus 3 square root of 8 over 3. We're almost done. Yeah? All we need to do is clean up the numbers here. Remember there, as you can see, we have some surds appearing. So let's take care of that slowly. The numerator, 3 times 1 over 3, we have 1. 1 over 27. So I'm going to have 1 minus 4 over 27. So I'll have 23 over 27. Okay, that's the numerator. The denominator, be careful. Let's see. I'm going to work this out here first. This part here. I'll have 4 times square root of 8 over 3 times square root of 8 over 3 times square root of 8 over 3. Just to help you along, yeah? So this will be 4 times 8 over 9 times square root of 8 over 3. Okay? So this will be 32 over 9. So let me write it here. 32 over 9 square root of 8 over 3 minus 3 square root of 8 over 3. Okay? Now, let me clean this up. Do this carefully, yeah? Let me maintain the number here. I won't disturb this. The denominator, I have 32 over 9. I have, this is 3. So that will be 27 over 9. So 32 minus 27 will be 5 over 9. So let's write it down. Okay, let's write it here. 23 over 27 over 5 over 9. Okay, this is 5 over 9 times square root of 8 over 3. Great. So now we have 23 over 27 times 27 over 5 square root of 8. Cancel the 27s. I have 23 over 5 square root of 8. Now we don't like the square root of 8 at the bottom, so let's multiply square root of 8 over square root of 8. So I have 23 square root of 8 over 8 times 5 is 40. What is square root of 8? 2 square root 2 over 40. Let me erase this, I don't need this now. So let me cancel this. 40 and 2, I have 20, so my final answer becomes 23 square root 2 over 20. And we are done.